When you're looking at a distribution, the three things you care about are the shape, the center, and the spread, right? The spread means how is the data spread out? Is it all in the middle? Is it evenly spread out over all the values? Is it piled up on one side but not so much on the other? Right? All of those have a different spread, and we need a way to quantify how much is it spread out. Now, the term standard deviation is actually a very specific term, but the word basically means the standard, meaning kind of the average difference from the mean, right? If all the data is in the middle, then there is no difference from the mean. The mean is always, all the data are the same thing. If it's all spread out, then it's going to be different. But just generally, what we're meaning by standard deviation, it's just the expected differences, right, between the data points. I mean, I don't even like using that, you know, because it's not really accurate to say average difference. But it's still just try to standard deviation, just trying to get at some kind of a measure of the difference between a data value and the middle. For example, look at these three sets of data. There's 5 data points in each one. What would be the median of each of those? Because they're all in order. What would be the median of each one? 3. The middle value is 3. Okay, what about the mean? 3. Right? Because notice, these are all 3s. Right? This one, so that's the average is 3. This one, the 1 and the 5 will add up to 6, divide by 2. There's a 3. 2 and the 4 will average to 3, so that's a 3. The 2 1s and the 2 5s, right, perfectly balance each other out. So the mean and the median are the same. But are the data the same? No, they're not the same at all. They're spread out differently, right? That's why we need a standard deviation. Now, I can show you the data that I had in there at the beginning. Let me clear my list. Second L1. And go back, stat, edit. Let me put back in the 1, 2, 3, 4, 5. Okay, now if I look at that histogram, you would expect that to be a uniform distribution because there's one of each, right? It should just be flat across like that. But notice what happens when I do this. All right, I'm going to go second, stat plot, 1. Okay, it's turned on. It's a histogram. It's taken it from list 1. And now I go zoom 9, and look what it looks like. It does not look like uniform. Okay? And the reason why, again, is because the way that the bins are being defined. The bins, like the width of each one of these rectangles, that's X values, right? X goes along the horizontal axis. If I wanted to show a uniform distribution, I need to set the bins correctly. And I would do that by going into the window, and I'm going to make the minimum, since actually my minimum value is 1, right? But I want my rectangle to be centered on 1. So let me start it at 0.5, which would be half below that, 0.5. And then since my maximum value will be 5, I'm going to make the maximum on this 5.5. And then I'll make each bin is 1 wide. So it'll go from 0.5 to 1.5, 1.5 to 2.5, 2.5 to 3.5. Right? Now I'll make my y values go from 0 to 5. And now instead of hitting zoom 9, just hit graph. And there you get every bin has got 1 in it, right, for 1, 2, 3, 4, 5. Okay. What would we expect it to look like if we graphed this one? The 3, 3, 3, 3, 3. One big bar in the middle, right? So if you go up to the second stat plot, 1, and let me go down in place of L1, I'm going to put L2. Second, L2. And graph. Just one big bar in the middle. Okay. What is it going to look like if I do the last one? Right. So let's see. Now I'll go like this. I'll go second stat plot, 1. Then we go down to the L2 and make it an L3. Second, L3, and graph. So you got 2 in the 1 column, 2 in the 5 column, and 1 in the 3 column. But they're all different, right? How this data is spread out is different, even though the mean and the median are the same.